this joint webinar with the Water Development Department has started as an idea at the beginning of this year. Because of the pandemic, we had to postpone it. Originally it was to happen in March, then in September, and now we finally are getting together in this virtual form, and I think it's promising to be an extremely interesting and informative webinar on dam safety, a subject which is very important, you know, for Cyprus and of course in other countries around the world having dams. Now we have 3 speakers and that extremely experienced in this particular field. I will introduce these speakers just before they present, but right now I would like to extend my sincere thanks to the director, senior management, and colleagues at the Water Development Department for giving us this opportunity to do this joint webinar. With this, I would like to welcome the director of the Water Development Department, Mr. Charalambos Hajibakos, and I would kindly request him to say a few welcoming words for opening this webinar on dam safety. Mr. Hajibakos.
Right, I am unmuted, I guess.
Yes,
right.
You are unmuted now.
Right, thank you very much for giving us this opportunity to address this webinar, which I think is very important, and we should have been doing it probably long ago. I would like definitely to thank the Cyprus Water Association for all the efforts they put in order to put together this webinar. It is most unfortunate that this seminar has to take place under the conditions of the coronavirus restrictions, because inevitably this would render the a contact between people much more difficult. My view of the seminars is giving the opportunity to people not just to listen to the presentations, but actually have the opportunity to talk to each other, exchange business cards, and make contacts in order to be able to have a follow-up. Okay, things they worked out the way they have. There isn't much we can do about that. Okay, I'm not going to have an official address. Don't expect me to read the text which my colleagues wrote for me last night. You are all aware, of course, that the Water Development Department is responsible for the protection and sustainable development of the water resources of the country, and therefore is responsible in that context for all the major dams of Cyprus. Cyprus, today, there's a legal framework governing the safety of dams, which comes under the Integrated Management of Water Law of 2010, plus the Safety Regulatory Act, which puts into perspective the safety procedures that need to be followed. Okay, historically, we all know that after the independence, a number of dams started to being built. Before 1960, not much has been happening. And of course, the initial attention was for building reservoirs and dams for irrigation. As things changed over time, population, water demand, climate change has led us to start building reservoirs, not just for irrigation, but also for water supply. The first dam we built in 1968 was Germasoia, which was just for irrigation. And today, I don't know how many dams we have, we lost track. We are building the latest one we have now under construction is the reservoir, the dam we are building at Persefanu, which is going to be used for storing a treated effluent from the wastewater treatment plant of Larnaca. So you think historically, you can see rather historically how things have changed over the last 50, 60 years. And I'm very fond, okay, it comes from my background professional, that how important it is the use of treated effluent for irrigation in the moment we can't afford to be losing any water anywhere. I remember 30 years ago when I got the job in the water development department, and I was, as an environmental engineer, and I was talking about water recycling, everybody was laughing at me. We won't be giving sewage to people to irrigate. Today is our policy. So it just shows how things changed over time. I won't be saying, as I said, very much. As I said, the latest one we are building now is at Stefano, and also we have soon under construction 2 more reservoirs in Aradipo area, which are new in terms of design. The first ones we are doing in Cyprus, which are roller compacted concrete reservoirs. If I was to say that I know what exactly this is, I would be lying to you. Certainly is innovative in our case. However, now today we're talking about safety, and safety is very important for our dams. Most of them are built in catchment areas where we have residential areas. Any accidents, any problems, they could be really devastating. And we have seen, I think recently it was in Brazil, what it means for a dam to collapse. Okay, we are not Brazil, but we cannot rest assured that these things can never happen in Cyprus. The Water Development Department has a monitoring system, as you all probably know, that follows the behavior of our dams, and we have a unit that follows what really happens in our dams. I have to admit, however, as a director, that I would expect from us, and I'm including myself into that we should be doing much more regarding the safety of our dams. Okay, I won't start crying and how understaffed we are, and threatening that I'll burn myself at the Eleftheria Square if they don't give more people. But certainly we have a problem of understaffing, and unfortunately, the understanding of the decision makers is that when you build a reservoir or when you lay a pipeline, because the pipeline is under the soil and you can't see it, then there's no problem with it. And when you have a dam, the moment you build it, you can be sure that it doesn't need anything from there on. Maintenance and follow-up, unfortunately, is not in the culture of the policymakers. And I see that every day, not just for reservoirs, I see it for our pumping stations, for our pipelines, everywhere. People think that the moment, not the technical people, not the water development department, but those who have the money, unfortunately, that they don't pay attention to these things. I hope that this initiative today by the Cyprus Water Association would give the impetus to move things to the direction as department and help us, assist us, whatever you want to call it, in order to pass over to those who make the decisions of how important dam safety is. I intend to use, in the good sense of the word, this webinar, this information and presentations to go to the higher levels of the government and try and explain the importance of safety of dams. I won't be saying much more. Actually, I didn't read anything from the the speech my Stella Bazzali wrote for me last night. I apologize for the trouble I put her into. I just wanted to express more than anything else my concerns, and also thank you for this initiative that I hope it would, as I said, give us more ammunition to go back to the decision makers and assist us in doing our job the way we want to do it. All right, I don't have much more to say. I thank you once more. I'll be staying with you for a few more minutes. Unfortunately, I have some other commitments after that. I don't know, now I'm talking technically now. I think Zoom, we're using now, has the chance or the option to record what's it called?
We are recording it.
Yeah, you are recording it, right, that's good. Because for those who won't be able, then we can upload it somewhere and people can watch it later on. Provided everybody agrees to that, which I take for granted that they do. All right, thanks very much again, and let's go ahead with it. Thank you.
Thank you very much, Mr. Hajibako, for your welcoming words and thoughts, and for stressing the importance of safety of dams, and a subject, which is obviously extremely important, in our case in Cyprus, having over 100 dams, large and small. But on this particular issue regarding dam safety in Cyprus, I think we have Dr. Kyriakos Kyrou, who has been dealing with dams, for the whole of his life, and it will be the subject matter of our first presentation by Dr. Kyrou regarding the dam safety in Cyprus. A little bit on how we're going to run the webinar. The presenters will give us their presentation for about 20 minutes. If you have any questions, you can put the questions in the chat. If you are too shy to put it in the chat and you want to put it across verbally, according to the time availability, we would be able to take some questions verbally as well. So immediately after each presentation, we will go ahead with questions if there are any, either from the chat box or someone wants to put a question verbally. A few words about Kyriakos Kyrou. Is a geotechnical consultant and a former director of the WDD. Has a long career in the WDD and worked on many projects and had major contribution and direct involvement and implementation of large development projects all over Cyprus, especially in the construction of earthfill and rockfill dams. He's headed the dam monitoring unit of the Water Development Department for more than 15 years, served for many years as secretary and subsequently president of the Cyprus National Committee on Large Dams. He has delivered many presentations in the field of water development, dam safety, and geotechnical engineering, and many, many other things that in the interest of time, I will not mention. Please, Kyriako, I kindly ask you to take the floor, share your presentation. You have approximately 20 minutes to conclude your presentation. Thank you.
Okay. Can you see the slides, Pampos?
No, it takes a few seconds from the time that you start sharing until we see it. Do you see anything on your computer?
What? Let's see.
Is the share screen coming up on your computer?
Share.
Yep. Coming up,
Is it okay now?
Yeah, yep.
Very good.
Go to your presentation, please.
Just give me a second. Load the program again. Okay.
Kyriakou, could you put it in present? Great, excellent. Thank you very much.
All right. Good morning, everybody. I would like to thank the organizers for asking me to deliver this short presentation. The subject of dam safety is really very wide, and I'll try and concentrate only on the current legislation in Cyprus. We avoid in this way to have an overlap with other two speakers. So let me start by giving a small introduction. The role of dams. The human race has been building dams for more than 5,000 years. And dams have been linked closely to the rise and decline of civilizations, especially to those cultures highly dependent upon irrigation. We know that the civilization started from Mesopotamia, and people have been building dams in order to divert water for irrigation. But dams were being built in Egypt, Yemen, India, China, and Persia. Dams were so important that there is a reference in the Quran about a small dam in Yemen, one of the most famous, I would say, dams in antiquity. It was built in 950 BC, and it was destroyed by an earthquake in 530 AD. The Quran refers to the great gardens of the Sabbadians. The people of Sabah had beautiful gardens with good fruits. And then the people turned away from God and he punished them. He burst the dam, turning the good gardens into gardens bearing bitter fruit. This is the small dam in Marib, 14 meters high, which has been in existence for nearly 1,500 years. Today, we are building gigantic dams, more than 300 meters high, storing billions and trillions of cubic meters of water. They are used for irrigation, domestic and industrial supply, flood control, navigation, production of electricity, recreational purposes, athletics, etc. This is the huge project in Itaipu, in Brazil, Paraguay, with an installed capacity of hydro 14,000 megawatts. This is the famous Oroville Dam in the United States, 235 meters high. And this is Aswan Dam, which is produced a lake, 5,250 square kilometers, which is about 60% of the size of Cyprus. And this is one of the most beautiful dams in the world in Canada, Daniel Johnson, with 13 arches. The central arch is 150 meters, I think, with a span of 160 meters. This was the highest dam in the world for about 30 years, Nurek Dam, with a total fill of 60 million cubic meters. And this was surpassed by this dam here. I'm trying to get rid of some of these. This is Nurek Dam in Tajikistan, which is 300 meters high with a fill of 60 million cubic meters. This is, I've got a problem here with the screen. All right. Qibing Dam in China, which is the highest dam in the world, is 305 meters high, 2014. This is probably one of the most impressive hydraulic projects in the world, the Three Gorges Dam in China. They used 27.2 million cubic meters of concrete for this dam, and it's got an installed capacity of hydro 22.5 gigawatt, 22,500 megawatts. Dam safety. As you understand, a large number of dams are located upstream of large cities, like the Aswan Dam in Cairo, which is upstream of Cairo, Folsom Dam, which is upstream of the city of Sacramento in California. So the safe operation of dams depends on many factors: design, construction, monitoring, maintenance. Dams do not become safer with time. We have a phrase in Cyprus, that is wrong. The dam does not become safer with time, so it needs frequent inspection. Statistically, 1% of the dams fail. Dam failures can be catastrophic, loss of life, and serious economic consequences. And I have a list of some dam failures here. The Mapasset Dam in France in 1959, it killed 421 people. The Vaillon Dam in Italy, 1962, killed 2,600 people. The Canyon Lake, it's a very small dam in America, South Dakota, 1972. It was only 6 meters high, but it killed 242 people and destroyed half of the city. The famous Teton Dam failure in 1976. And we've got some really major dam failures in India and China. The Machu Do in India, 5,000 people died approximately, and 2 dams collapsed in China in 1975, killing 171,000 people. This is what was left from Mapasset Dam in France. This is the Canyon Lake Dam. I want you to look at the section. Have a look at the section. It was a tiny dam, 600 meters high. People were being warned to get out of their houses, and if they thought it was a joke. The failure of the dam created a wave, with a maximum flow of 800 cubic meters per second. It destroyed the houses of about 40,000 inhabitants. This is the failure at Vaillon in Italy. They had a big slide here into the reservoir. Although the dam did not collapse, they had a wave of about 100 meters above the dam that killed 2,600 people. Coming back to Cyprus, between 1920 and 1960, Cypriots were using the aquifers. They were pumping huge aquifers, huge quantities of water from the aquifers. The aquifers were depleted. The coastal aquifers suffered from seawater intrusion. The newly established government realized that the development of surface water resources was of vital importance. The government decided to construct dams to store surface runoff and recharge depleted aquifers. The target was to prevent surface water to flow into the sea. This was an ambitious and expensive target due to steep topography, because our dams are very high compared to their capacity. In 1960, we had 6 million small dams with a total capacity of 6 million cubic meters. In the early 60s, a number of medium-sized dams were built for irrigation purposes, and these were mainly earth-filled dams built with locally available materials, and these include Pomosa, Ia Marina, and Argaga in the northwestern part of Cyprus, Mavrokolymbos in Paphos, and Polemidia upstream of the town of Limassol. They varied between 33 and 45 meters, and storage between 300,000 and 3.4 million cubic meters. This is the first dam with a capacity of more than 10 million cubic meters, the Ermasoia Dam. This is the first dam we built in Cyprus with a capacity, which was intended for the domestic supply of the city of Famagusta, the Efkara Dam. And then after the invasion, the government decided to implement 5 major projects: Paphos Irrigation, Vasilikos Pendassinos, Pitsilia Integrated Rural Development Project, Chrysochou Irrigation Project, and the Southern Conveyor. Obviously, large dams form the key components of those projects, and these include Asprokramos Dam, Dipodamos, Galavasos, Xiliatos, Evretou, Arminou, Kouris, Achna. This is the highest dam in Cyprus, with a height of 113 meters, capacity 115 million. This graph here shows the dam construction progress in Cyprus, and you can see that between 1980 and 1990, we've added 230 million cubic meters of capacity to our dams. Dam safety in Cyprus now. Most of the large dams in Cyprus go to the Water Development Department, and some smaller dams belong to local irrigation divisions. Towards the end of the intense dam construction activity around 1990, it became obvious that systematic dam safety procedures had to be established. For many years, dam safety issues, inspections, etc., instrumentation monitoring, etc., were addressed by the experienced engineers of WDD in collaboration with the consultants, because the consultants were mainly here, some of them finishing their projects, some of them not. So all this work was being carried out by the engineers of the Water Development Department. Before I go to other issues, I want to show you this graph here. Many people feel that because we've got dry conditions, we've got no problems with dam. But I want you to have a look at this graph, because here it shows a period where our dams were practically empty for 5 years. And this is no good for dams. Some of our consultants were worried that these continuous droughts could cause cracking of the clay cores of our earthfield dams. So the Integrated Water Management Law, this is a law that was passed in 2010 after lengthy and laborious discussions, objections, and disagreements. There are provisions in the law for the safety of dams. We've got articles 56 to 79. These provisions are based on the Reservoirs Act of 1975 of the UK. Obviously, we have adapted the Reservoirs Act to suit the local conditions. So, similar to the UK Act, a large raised reservoir is a reservoir capable of storing more than 25,000 cubic meters of water above the natural ground level. The law covers all large raised reservoirs, whether constructed under the provisions of the law or not. The law covers all large raised reservoirs, i.e. those storing fresh water, recycled water, sewage, and liquid waste. The director of WDD ensures that all dam undertakers, those that are running the dams, including the director of the Water Development Department himself, comply with the provisions of the law. The director of WDD maintains a register of all large dams in Cyprus, with details about each dam, basically. Undertakers maintain records of water levels, settlements, leakages, and other instrumentation measurements. They keep proper records, which they have to communicate these records to the director of the water development. The director prepares a yearly report for the Minister of Agriculture with information about each dam and comments about the recommendations of the supervising engineer and the inspecting engineer, and the degree of implementation of the recommendations that involve safety issues. We will see in a minute what we mean by supervising engineer and inspecting engineer. For this purpose, the ministry maintains a panel of qualified engineers, i.e. we've got 3 categories: the supervising engineers, the construction engineers, and the inspection engineers referees. The registration can be done by application to the director and approval of the Minister of Agriculture. Panel engineers must be employed for nearly all major activities involving dams. In the case of construction of a dam, enlargement, reuse of a dam, a construction engineer must be employed for the design, supervision, and issue of certificates. This is very important. Not just do the design, but he has to supervise it and issue the appropriate certificates. Periodic inspections. An independent inspecting engineer must be employed 2 years after issue of the final certificate for every dam, and after modifications that affect the safety of the dam, or when recommended by the supervising engineer, or 10 years after the last inspection. Supervision of a dam. When a dam is not under the responsibility of the construction engineer, in other words, it's finished, a supervising engineer must be employed to supervise the dam and give updated information on to the undertakers regarding the behavior of the dam and the issues that may affect its safety, and ensure that they comply with the provisions of the law. They have to have somebody, a qualified engineer, to supervise the dam and go and visit them, check the instrumentation, and report to them whether there are any issues that involve safety. If we modify a dam to store more than 25,000 cubic meters of water, or if we abandon a dam, a qualified engineer must be employed to issue the relevant certificate and or prepare a report. The director of the water development has got some extraordinary powers. If the undertakers of a dam fail to comply, to employ a qualified engineer when instructed by the director under the provisions of the law, then a qualified engineer can be appointed by the director. If the undertakers of a dam fail to implement a recommendation relating to the safety of the dam, the director may implement the recommendation by employing a qualified engineer himself. If the director considers that a dam is unsafe, he can take any appropriate action. All expenses are paid by the undertakers. In case the undertakers, the users of the dam, in other words, disagree with the implementation of measures recommended by the supervising engineer, the inspecting engineer, or the arbitrator, an arbitrator must be appointed. In case of disagreement, the arbitrator can be appointed by the Council of Ministers. Reports by arbitrators, construction engineers, supervising engineers with recommendations must be communicated to the director. When the undertakers intend to construct, modify, abandon a dam, inform the director 21 days before commencement of any works. Other provisions, failure to comply with the provisions of the law is a very serious offense, and there are severe sentences, including jail sentence. Dams constructed before entry into force of the law must be inspected by an inspecting engineer, and who is going to prepare a report with drawings and issue a certificate. My final comments is that the current legislation covers adequately all aspects of dam safety, with strict provisions regarding dam construction, enlargement, reuse, modification, abandonment, and normal operation. It gives extraordinary powers to the director of the Water Development Department to intervene when safety issues arise. The legislation aims to ensure that no dam safety issues arise, thus protecting human lives, properties, and the environment. Strict application of the law will ensure the safety of Cypriot dams. Thank you.
Thank you very much, Kyriakos, for this detailed presentation on the history of dams in Cyprus, the safety aspects, the legislation, and how important it is to keep the dams safe. Now, I have a question in the chat box that I will put to you, Kyriakos, from Panikos Pashas, and he's saying that he's asking a question, has any checklist been prepared by the Dam Society or from any other relevant organization in order to be used as a guideline following a devaluated earthquake? I have prepared one. As we know, Panikos Pashas is the chief engineer at the sovereign British areas. He has prepared one that is being used only within the sovereign British areas in Cyprus. So the question is, do we have such a similar list for checking dams after earthquakes?
I think we can make use of Panikos' list. We prepared in the past, before actually the law was passed, we prepared a list, a checklist, as Panikos says, for the inspection of the dams. But I'm not sure whether this checklist is being used today. And I'm sure the Water Development Department can make use of this list by Panikos. It will help all the supervising engineers to improve their monitoring of the dams. Yes.
Thank you very much, Kyriakos, for that. The understanding is that there is such a list, It was prepared in the past, and I'm sure it's been kept up to date, knowing that the Water Development Department, has the staff allocated, for such purposes under these circumstances for carrying out inspections. From the little knowledge I have, I know that engineers in the Water Development Department are allocated certain dams, for carrying out certain tasks. So that is.
All I know is that there is a supervising engineer for each dam that belongs to the Water Development Department. But unfortunately, I'm not sure actually, but I think there are the private dams are not being monitored. There is no supervising engineers for these dams. And some of them are not small dams. Some of them are 20, 30 meters high.
Many thanks for Panikos Pashas for your answer, Kyriako. Picking on the point that you said about private dams, don't these dams come under the same legislation as the other dams?
They do come under the same legislation, and I think the director of the Water Development Department must approach these owners and ask them to appoint somebody for the inspection, for the supervision of these dams. Yes.
Okay. Point noted. Just another question. Just for the interest, how many dams do we have in total? I mentioned a figure of about more than 100, but I'm sure we do have a number. So
57 dams in the ICORT register of the International Commission of Large Dams. These are the dams that are considered to be large dams for ICORT. But let me say that some dams which are not included in the ICORT register are also large dams with the current registration. They are also large dams. Yeah.
Question: the 57 dams that are registered in the ICORT have a supervising engineer designated. Other smaller dams, do they also come under the legislation?
All I know is that the major dams of the Water Development Department have a supervising engineer. But in the list of the 57 dams, there are private dams as well, mostly ponds. Some of these ponds, earthfill ponds, are up to 30, 35 meters high. I don't really know whether they have a supervising engineer, but I believe they don't.
Right. In your opinion, should they have a supervising engineer?
Well, somebody to at least check once a year these ponds and make sure that they're safe.
Very good point taken. You mentioned again, the questions keep coming in. You mentioned again ponds. Do we have a number for these? I mean, we're talking about many, or just?
We have about 22 ponds. That's all I know. Probably have more now. About 22 ponds that belong to irrigation divisions, but there are a few ponds that belong to some developers and other individuals. Some of them are not large dams.
Right. Again, another question from Panikos Pashas. He says, I understand that under the law, the undertaker is the director of the Water Development Department with the exemption of the small private dams. Who is the enforcement authority in this case? Is the Council of Ministers or the Minister of Agriculture?
The enforcing authority is the Minister of Agriculture.
Minister of Agriculture. Yeah. Thank you very much. Okay, I think, thanks very much. Any other questions in the chat box? Given time availability at the end, I will be putting to the speakers. There are questions coming in. Just to say that the Research Center kiosks of the University of Cyprus have just been informed by Pavlos now that they've got a puzzle on their Smart Water 2020 .eu platform, and it's a nice game of knowledge just to see if we know where the various dams in Cyprus are located. So in your spare time, you can really try this game out and improve your knowledge on dams in Cyprus. Giacomo, thank you very much indeed, for your excellent and extremely interesting presentation. We will move on now to our next presentation. Our next presentation is a joint one by Neil Harding and Tom Butler. They are both directors of Reservoir and Water Services UK. The first presentation, which is a joint one, it will be on reservoir monitoring. A few words about both our next speakers, whom we thank for our availability to share their knowledge and experience on this. Neil, as I said, is a director of the Reservoir Water Services based in the UK. He's got 41 years of experience, both in public and private sector. He has been a supervising engineer since 2009 and currently supervises 86 reservoirs across England and Scotland, and has an extensive experience of reservoir surveillance, monitoring, operation, and maintenance. He provides training for reservoir owners, their operations and maintenance staff, and is currently producing a course for management of reservoir incidents. If we have time, Neil is going to present a 5-minute presentation on some of these incidents that he has come across recently. Tom has got more than 11 years of reservoir experience, including design and monitoring. He's got over 20 years as a civil engineer, extensive experience in the wastewater, flood defense, and other water sectors. He's been working towards his qualification as a supervising engineer and chartered engineer, and he is well experienced in reservoir surveying, specializing in bathymetric, 3D laser scanning, topographic, and deformation surveying techniques. With this, I would kindly request Neil to share his presentation, the first one on reservoir monitoring. Neil, the screen is yours.
Thank you, Bambos. Just get this back to the beginning.
Yep.
There we go. Hope everybody can hear me. Thank you for the introduction. Very interesting paper beforehand. Very good. I might add some comments later if there's time at the end of these presentations me and Tom will give. So good morning to you all from Tom and myself from what is rather a grey, gloomy and wet England. We know where we would rather be, folks, and it's definitely over there with you.
Yeah, most
perhaps another time. We hope you'll find this presentation of interest. But first of all, we'd like to thank particularly you, Bambos, but everybody for giving us the opportunity to make these presentations. We are always keen to spread the word through our own personal experiences, because we know that we will also learn a great deal from that process as well. So it's of mutual benefit. The presentations, both of them that we will give, are presented from my experience as a supervising engineer in the UK and our joint knowledge and experience of many years of monitoring numerous dams. The term UK is going to be used to describe England, Scotland, Wales and Northern Ireland. forget all about Brexit and the evolution and all that stuff. I'm just going to stick to all of it because the same dam legislation, dam safety legislation exists in all of those 4 parts of the UK, except Northern Ireland, which doesn't have any legislation at the moment. But it's fair to say that each country's legislation differs slightly in some respect, but they all share a common ancestry that goes back to 1930, following a couple of major dam failures with loss of life. And they all have requirements that are very similar for the topics that we're going to cover in this presentation. We will cover these topics, and our aim is to illustrate typical monitoring practices here in the UK, who does that monitoring, and the legal framework that stipulates what needs to be done. It might be useful quickly to provide a comparison of terminology between Cyprus and the UK. In England, the operator of a reservoir, which is not necessarily the owner of the reservoir, is termed the undertaker. I understand that you might also use the word operator as well as undertaker. I'm going to use both in this, just to avoid any doubt. They both mean the same thing. You have 3 classes of engineer. Category 1 being the supervising engineer, category 2 being the construction engineer, and category 3 the inspecting engineer. In the UK, we have supervising engineers and inspecting engineers, but the inspecting engineer can also undertake the role of construction engineer, whereas the supervising engineer cannot. So, getting into monitoring of dams and the equipment associated with the control and management of water into and out of the reservoir. This is vital to understanding whether the reservoir and equipment perform as expected and to provide long-term data that enable unusual trends in the behaviour of the dam to be identified in a timely manner to avoid safety problems, basically. It's a legal duty in the UK to perform monitoring and maintain records, and the same now applies in Cyprus. And this was touched upon in a previous paper. Monitoring is performed by the reservoir undertaker. Some monitoring is conducted for operational purposes and also to record the performance of the structure of the dam and its fixtures such as valves, gates, weirs, etc. The supervising engineer is obliged to ensure that the operator keeps records of the monitoring and also to assess the data from that monitoring to identify if there are any unexpected or unusual trends in the data. So, for example, has the dam settled more than would be expected from the design calculations? The supervising engineer is required to include a section in the annual report that is produced about the reservoir. And about the operator's monitoring and an assessment of that data. That report has to be sent to both the reservoir operator and to the enforcement authority, which in England is undertaken by the Department of the Environment, Food and Rural Affairs. Bit of a mouthful, normally called DEFRA. It's one of the major departments within the government. They review the legal performance of the undertakers to make sure that they are complying with all of the regulations and they are not slow in using their enforcement powers to seek prosecution where things aren't done how they should be. Recent change to the law in England has given a new power to supervising engineers, enabling them to issue instructions to the operators of reservoirs to conduct additional or new monitoring where it's believed that there could be an issue with the dam that might affect its safety and for which the monitoring is required. The construction and inspecting engineers will usually recommend what is to be monitored and at what frequency. The operator of a dam has a legal duty to follow those instructions, as does the supervising engineer to review the data collected and to report upon it. The undertaker is often able to select the methods of monitoring and the equipment to be used. In my experience as a supervising engineer, it is always a good idea to inform those who will actually do the monitoring why it and they are so important, as it is those people who will see the reservoir, the dam, more often than most other staff, and they provide an ideal means of observing anything unusual and then reporting it quickly to catch problems before they develop too far. So, what is monitored? There are two main aspects of a reservoir where monitoring is required in relation to the safety of the dam. Things are associated with the water being stored and the dam itself and all its fittings. From a dam safety perspective, the normal parameters to be measured include the water level, discharge from the dam, as well as on occasions the inflow to it, although that is normally only used at non-impounding reservoirs where the water is pumped into the storage reservoir. The chemical and biological aspects of water are often measured, but these are normally only relevant for water quality purposes in water supply reservoirs and not so much used for dam safety purposes. In terms of monitoring the dam itself and its various elements, the monitoring normally focuses on movement and condition. Has anything moved more than expected? Typically settlement or deformation of embankments? Is the condition of fittings adequate and do they operate as required? Absolutely critical, that one. Different methods are employed to monitor each of these, and we shall now explore some of the more typical methods that are used in the UK. There's no fixed frequency of monitoring for each measurement. The figures in this table are typical. Every reservoir is unique, and frequencies of monitoring need to take into account things such as the type of dam construction, variation in the water level and how that might change during operation cycles, and the age of the dam. Every dam is getting older, and just like your car, the older it gets, the more tender loving care it needs to keep it going properly. It's often possible to reduce the frequency of monitoring after a dam is built or altered when its performance has been shown to follow predictable trends, but equally importantly, to increase those frequencies when unusual trends are observed. We're getting on to how we conduct monitoring here in the UK. Looking at some of the typical measurements and starting with water level, the three common methods used include visual observations using a water level board, which obviously needs somebody to go and have a look at it, or using digital methods. The typical ones we use are ultrasonic methods made from above the water by reflecting a signal off the water surface to measure the distance down to the water, or by using submerged pressure sensors under the water that measure the depth of water above the sensor. The advantage with the digital methods is that they can be linked via telemetry and have automatic alarms included within that telemetry so that notifications are sent to key personnel advising them of sudden or unexpected rises or drops in water level. Another very growing Common practice in monitoring is the use of remote CCTV, again linked by telemetry, with cameras provided to look at key components of the dam. Valves, weirs, spillways, etc. These need to operate 24 hours a day, and having an infrared lighting facility built in is a very useful feature to include. One interesting recent development on that is if you are using infrared, just remember it cannot see anything that is red. So don't paint valve handles or have red numbers on your gauge boards because it can't see them. Black is good, or any dark colour. But be aware, these can be prone to vandal damage, and we also suffer from the mess that birds tend to leave on them. They like to perch on these things. Leakage from dams is obviously of concern if it's unexpected. It's very important to monitor in real time so that any unexpected changes can be observed and reacted to rapidly. Digital monitoring methods for measuring the water level, as we've just looked at, can be used with things such as V-notch weirs to measure accurately the changing leakage rate, as indicated by the graph below, to see whether or not the leakage, any changes in the leakage, represent normal operating characteristics or if they're exhibiting an unusual and unexpected change. Monitoring movement of the dam or its deformation requires precision measurements. The frequency of those measurements can vary, as I've mentioned before. It's normal practice here to measure the deformation of dams every 2 or 3 years, sometimes less than that, using permanent reference stations, such as the pin that you can see in that bottom left image, fixed to key components of the dam and its structures. Crack monitoring is usually conducted more frequently. Measurements will be made even more frequently when any unexpected movement occurs. Cracks can widen and close up. Again, the longer term monitoring will show whether or not this is normal or exceptional behaviour. It's a duty of the supervising engineer to assess the monitoring data to see if there has been an unexpected trend in the data. The undertaker can do this as well for their own benefit, but the duty rests with the supervising engineer to make that assessment and to assist the undertaker in understanding what is going on with their dam. Settlement of embankment dams is nearly always monitored due to expected consolidation and settlement. They will be expected to settle, but heave or rebound, as we call it, can occur with fluctuating water level. So having a long-term data set of monitoring measurements becomes important in being able to differentiate between these and any unexpected movements. Looking at valves, everybody's valve looks like those in that left-hand image, don't they? Unfortunately, as a supervising engineer, I see an awful lot that look like the image on the right. Valves are a very important aspect of a reservoir. They perform a critical task and need to operate properly whenever required. Monitoring their condition is vital, and recording each time they are operated, here in the UK at least, is a legal requirement. In many instances, it's also useful to know the extent of opening of a valve. Is it fully closed or just partially? And there are various methods that can be used to measure and record this. Siltation is a problem in many reservoirs, and the operation of scour valves to flush away silt where it's collected behind the dam is nearly always recommended by inspecting engineers to be conducted typically at least once every year, So the valve is operated over its full range until water runs clear and the silt around the valve has been flushed away. Monitoring where silt has been deposited is becoming more commonplace as dams get older and more silt is being brought in to the reservoir, as this reduces the volume of stored water and which can have economic or supply consequences. Different methods can be used to measure the silt, which Tom will touch on now as I hand over to him to look at some of the practical monitoring methods that we commonly see across the UK. Over to you, Tom.
Thanks, Neil. Neil's covered some of the importance of monitoring and how it would be good, and now I thought it would be good to cover how we complete some of these tasks and the type of surveys that we do actually undertake. Many people will be familiar with traditional topographical surveys, which provide accurate 3D points and surveys plotting the location of the features based on individual particular survey points. For large areas now, we can use UAV or drones to capture a much higher density of data, and to be honest, in a much more of a fraction of the time. This will create a ground terrain model and can be used for more than just standard topographical surveys. Neil mentioned deformation monitoring. These surveys are typically used for monitoring movement of structures such as dam crests, walls or tunnels. Monitoring is repeated at regular intervals and is achieved using precise total stations or digital levels, all referenced back to known static benchmark readings. Typically, sub-millimeter measurements are required, and it's certainly achievable when undertaken in the correct way. Next slide, Neil. A great way to capture a full three-dimensional profile of a structure is to complete what we do the 3D point cloud surveys known as 3D laser scans. These also provide high definition, 360-degree photos throughout the survey. With every tight data registration, accuracies of about between 3 to 4 mil are certainly achievable in this type of survey. And this survey is typically used to provide a full record of valves, pipework, connections, cracks, displacements. Once scanned, any measurement and photographic evidence can be taken, and if needed, repetitive surveys can be completed to monitor any change. 3D point cloud surveys are fantastic and regularly used prior to starting any projects where engineers can visualize all aspects of the structure. They can take measurements of everything or anything, including very small detail like the size of bolts, which can be aided during the design process. The pictures on the right contain sections from model data. This is often known as BIM or Building Information Modeling, which provides a very easy visual means to view the data from the point cloud dataset. Right, now moving on to our more sort of favourite type of surveys. Next slide. The hydrographic surveys are used to see and monitor what's actually under the water itself. Neil mentioned silt buildup and the importance of scour testing. There are many types of surveys and equipment that can be used to provide detail of what is actually underwater. The sub-bottom profiler provides a very thin beam that will penetrate through silt and provide a picture of what the strata layer buildup is underneath, which you can see from the top central picture. This equipment can be put on board a boat or attached to even remote control boats, and requires a lot of backwards and forwards movements across the water to build up a full picture of the bed profile. Detailed contour drawings and bed levels and top of silt, etc. Drawings can be provided, which then give you quantities of silt and water at different depths. We now use multi-beam sonar surveys, which provide data cloud or point cloud data sets under the water. These can then be merged with the laser scan sets above the water. You can see how visually pleasing the data looks from the middle row last picture. This type of survey is very common for dredging projects or measuring scouring of walls or bridge piers, as you can tell in that picture. Very lastly, ROVs or remotely operated vehicles are a great way to obtain imagery for visual condition inspections underwater. But I must stress, for taking accurate measurements, you do need the point cloud data from the multi-beam sonar survey. Neil, I'll pass it back to you now.
Thank you, Tom. Record keeping. It's a legal requirement to keep records of monitoring that's conducted. And this table compares what I understand from your position on Cyprus, and certainly from ours over here, what are the minimum requirements required. There might be others. The lists are not exhaustive. It's quite common for other measurements to be recorded on the recommendations of the inspecting engineer, or now from the supervising engineer. The frequency of those measurements can vary, as we've discussed earlier, but the importance of keeping those records cannot be overstressed. Our legislation in the UK is supplemented by a guide in which the legal content and the recommended format of the records is recorded. This is to give the undertaker of the reservoir the means by which to actually collect and then store those measurements that are to be legally gathered and retained, and then assessed by the supervising engineer. One of these statutory records is called the prescribed form of record, but we all know it as the Blue Book. No prizes for guessing why it's called the Blue Book. Just got to look at the colour of the cover. Like a log book for your car, or even your medical records for you as an individual. Every reservoir needs one of these by law, and it includes particular sections that are devoted to the recording of monitoring data. So turning to look at what's actually inside that document. The record has got 16 parts to it. I'll mention what the yellow highlighted ones are in a moment, but the other parts contain details about the dam, where it is, its volume, what it's made of, the engineers involved, drawings, emergency plans, dimensions, volumes, lots of technical details, as well as details of the undertaker, the enforcement authority, etc. So it's an ongoing record for that dam. It's its life history, but the 4 yellow highlighted sections include monitoring data. Part 1 is dedicated to recording water level data. And part 2 records all measurements associated with settlement and leakage. In part 15 is a list of all of the instrumentation at the reservoir for monitoring. And lastly, in part 16 is where all operation of valves, gates and penstocks is recorded. Again, it just highlights how important monitoring data is, in that the record for the reservoir has these specific sections within it. The guide also describes the prescribed contents of this annual report by the supervising engineer, the 10-yearly report by the inspecting engineer, and the certificates to be issued by the inspecting and construction engineers. So it's a very useful guide, very comprehensive, and it's revised at fairly regular intervals. The supervising engineer has to satisfy specific requirements before qualification. But I'm moving on here to really sort of explain how the supervising engineer's role in monitoring the data is critical, and how selection and approval of supervising engineers needs to include evidence from the applicants that they fully appreciate how monitoring is such a vital role of their future duties. They have to satisfy specific requirements before qualification onto the panel of supervising engineers. And once they qualify, unlike a doctor who's a doctor for life, a supervising engineer only has a 5-year period of qualification before they then need to reapply. They have various legal duties when appointed to supervise the reservoir. The appointment to look after a reservoir is made by the undertaker, and the undertaker can select anyone from that approved panel of supervising engineers, but normally makes the selection based on the engineer's familiarity with the type of dam. So somebody who has no experience of concrete arch dams would not be chosen. Conversely, somebody who has no idea about earth embankment dams would not be selected to look at an earth dam. They're also chosen on their proximity to where the dam is, in case there are incidents and the time that it takes for them to get there. As an illustration, an inspecting engineer, which can also be the construction engineer here in the UK, has more legal authority than the supervising engineer, but again is very focused on the monitoring aspect of their duty. But as with the supervising engineer, also only has a 5-year period before needing to reapply. So that concludes this presentation. I hope that's been of use, and I understand we'll now go into a period of any questions. Thank you.
Many thanks, Neil and Tom, for this extremely detailed and valuable presentation with regard to the effective monitoring and the legislative framework, that it's applied in the UK. Any questions at the moment? I don't see any questions, in the chat box. So, Neil, I during your presentation, I made some notes, and perhaps, I would ask to start with emergency plans in the case of an incident. Are there, is it the responsibility of the operator, or in the case in the UK, undertaker, to prepare this, and do these plans have to be approved by some authority?
Very good and very timely question, Boss. The next presentation will actually touch on some of the problems that can occur, and probably most of you, if not everybody involved in the webinar, might be familiar with a fairly major incident that happened here in the UK last year at the Toddbrook Reservoir. Probably very familiar and memorable because of the use of Chinook helicopters to deliver big bags of ballast to try and support a failing spillway. Quite a few of the water companies in the UK already have their own emergency plans for the reservoirs. It's normally driven from commercial requirements to satisfy the shareholders of the companies. It is not yet a legal duty to have an emergency plan for every reservoir. There are moves to make it a legal duty. In fact, the current legislation we have does include such a measure, but that measure is not yet active. There are moves to advance that, given last year's Toddbrook incident. And when it does become law, the format of it, the content of it, who approves it, and equally importantly, who will be responsible to rehearse it, to check that it operates properly, and to train up people in its deployment, has yet to be agreed. But I sense there is going to be quite a lot of movement in terms of bringing these into law and then making them a critical part of an undertaker's toolbox for how to respond to an incident. Incidents have a habit of coming out of nowhere. You don't expect them to occur, otherwise there wouldn't be an incident. And when they do, being prepared for them is worth its weight in gold. I can say from first-hand experience. Tom and I have responded to 5 emergencies this year. It's been somewhat busy this year, unusually so, and every single one sends the heart racing and the adrenaline pumping. When an undertaker has an emergency plan, even if it hasn't been looked at for a long time, we are always in a far better place than if he has nothing at all.
Absolutely. I personally, I'm a strong believer that emergency plans should come under a legal framework that, you know, can be enforced when they are needed, and particularly not only for the structure itself, but I would also go as far as the downstream conditions. And I'm coming to my next question is, in your capacity as a supervising engineer, what do you think the downstream conditions, for instance, you know, river beds or stream beds, should be monitored as well, should be inspected as well, in case we have such an emergency? And we've seen that we do get emergencies from time to time, both here in Cyprus and abroad.
Another very good question, Bambos. Just to let everybody know, we haven't rehearsed these questions beforehand. I've got no idea what Bambos is going to say.
I didn't think of the questions beforehand. It's just, you know.
I'll send it. I'll send the euros in the post, Bambos.
Thank you very much. I'll send you my IBAN.
Very good question. Just before I come to that aspect, I'll qualify or amplify a little bit more what I've just said about emergency plan. Here in the UK, for every reservoir, there will be 2 emergency plans. One that the undertaker creates, which is focused on what measures can be taken at the reservoir, purely at the reservoir, nowhere else. And the sort of issues covered will include access to it, monitoring data, key people, contact names, pumps, valves, focusing really on how to get water out of the reservoir if there's a need, or how to get to the reservoir to try and shore it up or undertake emergency repairs. The other plan focuses on the downstream catchment. Where would the water go if there was a catastrophic failure of the dam? Here in the UK, there have been 2 phases of modelling every dam to see what would happen to the water in a catastrophic failure. And you can go and see the results of that if you go onto the Environment Agency's website. I'm sure we can distribute links after the webinar, Bambos, because they show on there areas that are liable to flooding, whether from the sea, from rivers in severe storms, and most importantly for us, from reservoirs. They call it inundation mapping, and it shows the area that would be affected should the dam fail catastrophically. The plan that looks at the downstream area is not produced by the reservoir operator. It will be produced by the emergency response services, so the police, fire and rescue and ambulance, as well as the local government authorities responsible for administration of the areas downstream, and in the UK, the Environment Agency, who are responsible for the management of watercourses and rivers, which is where water would be expected to flow. Between those organisations, they will draw up plans to inform people, to warn them, to tell them to evacuate, where to evacuate to, what roads would need to be closed, what monitoring to be put in place. So there'll be a different level of responsibility for what would happen downstream compared to what will be happening at the reservoir, where the reservoir engineers would all be involved, again with the emergency services. These two plans would come together under the control of the police.
Right.
The police take control in a major incident. We have what are called gold, silver and bronze levels of control. And as you would expect, in the gold level, you've got the chief of police sat there taking advice from all of the knowledgeable people, the ambulance, the fire, and the reservoir engineers, feeding in information on which they will then make decisions. So it's a coordinated approach driven by those plans.
And of course, all these authorities that are involved in such incidents must be informed beforehand of such emergency plans and be aware and be prepared. So I mean, it goes without saying.
Yeah, and what is becoming more common is to actually rehearse these plans.
Right.
The plan that the undertaker has with the reservoir engineers and the staff who operate the valves, who maintain the reservoirs, the plan that looks at the downstream is beginning to be rehearsed and tested by the emergency services, and ultimately it's hoped that both plans will be tested at the same time. It trains everybody, it gives them reassurance and confidence that they know what they're doing, what they should be doing, and how to do it. And it identifies any gaps or weaknesses. It's absolutely essential.
Yeah.
You have some very big dams, and if you had a problem with one of those, it really does set the heart racing.
Yeah, absolutely. Many thanks, Neil and Tom, for the this presentation on reservoir monitoring. And Neil, I would kindly ask you to move on to our last presentation, which relates to reservoir operation and maintenance. I think we're doing well with time, and we should be concluding on time. So please, if you can share your next presentation, that would be great.
Okay, hopefully you can see this.
Yeah.
Good, we're halfway there then. Well,
Yeah,
hello again. This presentation is going to look at common practices involved with the operation and maintenance of reservoirs in England, from the perspective of the supervising engineer. I've had a small amount of direct involvement operating and maintaining reservoirs in the UK, but this paper is presented from the eyes of the supervising engineer role rather than the operator. The observant among you will see one image of a reservoir on Cyprus, but I'm not going to say any more than that. When a reservoir is constructed, the construction engineer who oversees the design and the construction phases issues certificates, as is the case over on Cyprus. And what is common practice here is at the end of that period, what's called an operation and maintenance manual is also created, normally by the designer of the dam. And this is for use specifically by the undertaker, by the operator of the reservoir going forwards. It gives details of the ways in which the reservoir should be operated, the equipment involved, so all the valves, weirs, etc., and how the the dam should be, and all the equipment should be maintained until such time as the inspecting engineer comes along, 2 years after the dam is built, and then at 10 yearly intervals, when they can issue additional recommendations or advice as regards operational maintenance and monitoring to be undertaken. Effective operation of a reservoir should be ensured by detailed written instructions and procedures put into effect by staff who are well trained. Those are very good aims and objectives seen here. The procedures normally cover actions that are designed to ensure that the reservoir can supply the required quantity of water of a suitable quality for treatment and then distribution, or for irrigation purposes. It's fair to say we also have many reservoirs in the UK that we call amenity reservoirs, which were usually built to improve the appearance of large country estates. People who had more money than they knew what to do with and wanted to look out of the windows at something that looked very good. These have their own particular problems, and their operators don't always devote sufficient effort to their maintenance. We also have a great number of what are called flood storage reservoirs that are normally empty, but can fill very rapidly in storm conditions and are designed to protect property or critical assets downstream. These have slightly different operating procedures, and the staff involved with operating them need special training. And as we've just talked about, emergency plans, the last item there on the list, although they're not yet a legal requirement in England, they are expected to become so. If you speak to any reservoir engineer over here, and if we were all betting people, we would all be putting money on the table on this one. The plans, as I've just mentioned, describe what actions should be put into place to operate the reservoir to try and mitigate damage and the catastrophic release of water through the dam. And these can be tested with the supervising engineer to prepare the undertaker's staff in advance of a real event and to identify gaps or omissions in the procedures. So looking at what do we consider to be good practice? Training of the staff that operate reservoirs is something that is, in my opinion, not given the priority it requires. I've found that well-informed staff, when they do get training and time is taken to involve them in how the reservoir operates and what it's for, they take pride in their work. Once they appreciate how important their role is, it makes them feel better and trusted and valued by their employer. One way to do this that I've found definitely works is to provide awareness sessions to staff who undertake completely different roles, whether they're key high-level management, right the way down to the guy that greases the valves and takes the readings from monitoring equipment. Everybody is important and plays vital roles, and understanding where they fit within that structure should not be overlooked. The topic shown, and there can be others, when they're explained to staff who are encouraged to ask questions and suggest possible improvements, they learn so much. And it never goes away. Once they've learned a little bit, that information they want to share with others who they come across. And ultimately, when those staff are informed and they become knowledgeable, they operate and maintain reservoirs to a higher standard, which is something that benefits everybody. Having written procedures, how to operate the reservoir, I've already mentioned, it is very important. Defining roles and responsibilities for everybody involved in that process is also essential, and are made more effective when those procedures are reviewed regularly. It's no use having them in a folder kept on a shelf collecting dust. They've got to be looked at on a very frequent basis. Every key component involved in the operation of a reservoir needs to have a program of regular operation, even if it's not used very often. When you take your car for its MOT, the chap in the garage will check absolutely everything. You may not have tested the lights or the horn on the car, but he will. And if it doesn't pass, then you can't drive that car. We have to treat our reservoirs in exactly the same way. Some operators have learned the need for succession planning, having the right people within the organisation who can take on different responsibilities as people move on or retire. And having a progressive career structure designed to retain key members of staff and provide the opportunity for everyone to improve their knowledge and experience is something that not many organisations are currently doing. But if the situation is the same in Cyprus as here, finding and attracting suitable engineers with an interest in reservoirs is becoming a problem. The number of reservoir engineers over here is declining. The number of reservoirs is increasing. The age of reservoirs and engineers, I'm no spring chicken, is also increasing. We have a problem coming up. So succession planning is something we consider to be vital in being able to operate and maintain our reservoirs properly. And something we take very seriously is provision of safe working environments with attention to details described here, which help to reduce accidents, but also raise morale and productivity, and should never be overlooked. We have many forms of legislation here looking specifically at health and safety, and they all relate to reservoir work, and some specifically, such as confined spaces going inside dams, are very robustly enforced over here. Looking at some of the key components and how to operate and maintain them, valves. Valves need a lot of attention to make sure they continue to operate properly. They're highly stressed assets working in a hostile environment and need regular operation to keep them working properly. Manually operated valves and electrically operated. You can see on top of the two valves on the right, square valves, there are, we call them rotorks. They are electrically driven motors that raise or lower the valves. And I don't think I need to say how the valve in the middle is operated, it speaks for itself. All of them require the same level of attention in operating them and maintaining them, because those valves have all got to do the same job. Well, you have check valves or guard valves that are only operated once in a while when the valve that is normally used is taken out of operation for maintenance. If that check valve doesn't work, then there's no way of working on the normal valve. Personally, I found that the addition of a very simple sign to a valve stating its purpose, which way to turn it to open or close it, and the number of turns required to fully open and close the valve is a very useful addition and helps those who need to operate the valve, particularly if they're not that familiar with the valve and are called in at short notice to go and open or close it. Or anything that moves needs lubrication. So all bearings and other moving parts need regular lubrication. Remote lubrication can be installed for hard to reach components, as shown by the red arrow. That thin tube enables somebody to apply grease to the bearing at the lower end of that bearing from the top, meaning that they don't need to get into somewhere that's very awkward or dangerous to get to. little measure that can make a big difference to the people who do the maintenance. Cables on winches all need to be unwound and checked for defects, and again lubricated with grease. All electric motors and pumps should be tested. Gates, sluices and valves should all be operated over their full range at least once every year. Spillways. Spillways, and in particular the joints in spillways, has received a lot of attention, as I mentioned earlier in response to Bambus's question, particularly following the event last year at the Toddbrook Reservoir. In fact, you'll see a photograph shortly of just what can go wrong if things such as vegetation is allowed to grow in those joints. Defective joints are being identified as a way for damage to occur due to the high forces imposed by fast flowing water going across the spillway. Removal of all vegetation is very important to retain structural integrity of the spillway by stopping water getting into the gaps where obviously vegetation has grown and water could then flow. Similarly, repair of defective sealant and mortar joints in walls and panels is recognised as being of great importance here. The wall on the left is a spillway wall. You can see the horizontal and vertical cracking between the masonry, and on the right is a mastic joint in a channel wall, which if you put your finger under that white mastic, you can simply pull that out with no effort at all. Just imagine the damage that water could do in there. The force of water in a spillway should not be underestimated. We get a lot of rain over here, as you know, and conversely, I know you don't get that much. But when a spillway operates, all hell can break loose. Water will do what it wants to do. It takes no prisoners. Like an airbag in a car, the spillway needs to operate properly the first time of asking. And it's got to operate in extreme conditions. And it is good practice here to do periodic tests of spillways under controlled conditions to see just how they perform. The picture on the left is a reservoir in Wales, and the one on the right, I will show you a photograph of what happened after all that water that you see cascading down the spillway had caused some damage. If you don't look after your spillways, this is what can happen. The top left image shows where stones can be pulled out from the walls or the bottom of channels by the suction forces created by the water. Those forces are immense. And once that occurs, the damage, as shown by the image in the bottom left corner, can very rapidly occur. And see how the channel has been destroyed. The dam is on the left of that image. You can see how the dam is being washed away by the flow of water once it's got out of the spillway. The larger, slightly blurred image on the right is Toddbrook Reservoir from the incident last year. And again, you can see the damage caused underneath the spillway once water was able to get beneath those concrete slabs and start to wash away the material underneath. The spillways are absolutely essential, and their effective maintenance is critical to the safety of a dam. We also have reservoirs where you have a membrane, typically on top of an earth embankment for irrigation reservoirs, where a plastic liner is used. It's relatively quick, simple, and cheap to deploy, particularly where use of clay or asphalt or concrete is not readily available. But these have different problems. holes, punctures, and where plastic sheeting is welded together, those welds can come apart over time. Holes and tears need to be repaired quickly. And what we find is good practice here is when the water level is low, is to inspect all of the liner right the way down to the bottom. This normally involves somebody being lowered down on a rope or and a harness from the top to walk all over the liner to look for holes, to mark them up with spray paint as shown on the left, and for a reputable company to come in to clean and then repair the holes. It's amazing how much damage water can do when it gets out of such a small hole. Water is precious. We want to keep it in the dam and not lose it. Similarly, the condition of the dam is important to us, and ensuring that it's in good structural condition. And these are not pictures of good structural condition, I hasten to add. This is what we want to avoid. Dams should not be allowed to get into this condition. On the right is an earth embankment. You can see how the bank has slipped. And on the left, very poor condition concrete. But that pier is supporting a critical element of the dam. That needs some serious attention. Concrete will degrade over time, so we have to keep looking at it, monitoring its condition, as I said earlier, and repairing it before the cost of repairs becomes exorbitant because we've let the problem develop too far. We talked about spillways just now, and the approach from the reservoir into the spillway is equally important. When the spillway needs to operate, it's vital that water can get to it unobstructed. These two images, one from Cyprus, one from England, no prizes for guessing which one's which, show how vegetation in the approach can restrict the flow of water. Getting rid of the vegetation is important to make sure the water can flow freely. If you don't, that vegetation will be lifted and moved by fast flowing water and can easily cause blockages downstream. So we've got to look at and ensure that any vegetation is effectively controlled. Many supervising engineers here use the phrase, anything growing on a dam other than well-maintained grass is a problem. And as you can see here, this is a reservoir I supervise. I hope you agree that having vegetation like that on an earth embankment is not good. The undertaker let the growth of little trees get away and they've become big trees. Big trees have big roots. Big roots try to find water. Water's in the dam, the roots head towards, the water's in the reservoir, the roots try to find their way through the dam to the water. Not good. So controlling the growth of trees and other vegetation on a dam is very important. It's also a legal requirement to maintain records of the operation of certain parts of the dam, as I mentioned before, with monitoring. Similarly, the extent of operating of valves, again, going back to the last part of the official register for every dam, in part 16 is a legal requirement that every time a valve, a gate or a penstock is operated, it must be entered into the record book. And many undertakers here also choose to add additional parts to the record book for their own benefit to record when they operate other parts of the reservoir. Aerators or diffusers to try and rotate the water and improve its quality. They are recorded as well. Something I would like to just insert here, if I may, Bambos, which is slightly in addition to the copy of the presentation I've sent you, is I'd like to refer you to the British Dam Society website, because it has an excellent library of reference documents on it that focus on monitoring, operation and maintenance, as well as many other things too that are of great use as background reading and for providing experience of engineers, both in the UK and internationally. Again, I can send the link, but for those who want to write it down, the website's easy to remember. It's just called British Dams, no spaces, just britishDams.org. And if you go in there, there are lots of reference documents, papers, guidance, etc. that's available, including good practice for operation and maintenance. But that concludes our presentation on the experiences of supervising engineers, surveyors and those doing the monitoring, operation and maintenance in the UK. And I believe we've now got an opportunity for questions. So back to you, Bambos. Thank you very much.
Thank you very much, Neil. I just put in the chat box BritishDams.org. That was
BritishDams.org. That's it.
Yeah. Okay. So that's if anyone wants to look it up, then there's a lot of information in there, as Neil said. Now we have about 10 minutes before we close. Again, Neil, many thanks, for the extremely informative presentation on the reservoir operation and maintenance. Great deal of information in there to absorb. We have one question, by Yannis Papazoglu, and he is referring to the electromechanical equipment in the dams. And his question is there a protocol regarding the preventive maintenance of electromechanical equipment, or should we solely depend on the O&M manuals that are provided with the dam? I think you have made reference to that in your presentation with regard to planned and reactive maintenance, but how do we respond, to this particular question, Neil?
Very good question, thank you. The operation and maintenance manual should describe all of the key components, including mechanical and electrical. What is common practice for us is to refer to the manufacturer's guidance, coupled with how the equipment will then be used once it's been installed. So it's a combination of two things. The supplier, the manufacturer of the equipment, will advise on the loadings, the sorts of maintenance, limitations to use of the equipment, but the day-to-day operation of it will be based upon experience and the use for which each item is actually being put. So, for example, a pump, it may only be used once a year to get water out of a shaft, whereas the manufacturer may say should be tested every 3 months. In those situations, the engineer, the supervising or inspecting engineer, would want to see that the supplier, the manufacturer's instructions are being followed and not just those of the operator, because the more onerous of the two criteria should be adopted. So it's common practice for the reservoir engineers, once they become involved with a reservoir, to find out exactly what the recommended frequencies and types of operation and maintenance are stipulated for every component, just to make sure that things aren't overlooked.
Thank you. Thank you very much, Neil. We do have a few more minutes, and I would like to touch upon a specific aspect that you mentioned in your presentation with regard to the training of staff. and you refer to it as, formalized training. And we know many employers, they don't like their staff, or they feel that, if this takes the form and shape of regular trainings and people not being at work, most of the time, because they're away on trainings, they don't really favor that. So what exactly, is it meant by formalized training? Sort of time allocation to that, and what do you think should be the intervals that, staff that are responsible for dams, one way or another, should allocate for this purpose?
A good question. Training is vital, and continuity of knowledge within the people who are actually involved with the reservoir, as I've mentioned, succession training is also vital. There can be a mixture of formalised and informal training. They both work well. We have legislation and regulations here, particularly involved with water supply, that require people to have a degree of formalised, accredited training that's recognised nationally, like you would have at school with exams, where to be involved with operating a reservoir, you must have a particular or various pieces of training that's formalised. They're normally one-off and can range from a day for fairly basic things up to maybe 2 or 3 days for some serious training on particular key elements of a dam, where there's a lot of responsibility on the people and their role with that dam. So the length of the training varies with the importance of it. Informally, it works best when it's on the job training. So you're actually meeting with the people doing their day-to-day job, sitting them down for a short period to explain why they're doing what they're doing legally and in terms of the safety of the dam. So they've got the background and awareness to what that work is. And then to actually turn the event around so that the audience is telling the trainer what they do, how they do it, whether they think it's done as well as it could be, to offer opinions. That process works very well. It's also productive because the last part of that process means going to the reservoir to actually see what they're doing, to go through the motions, operating valves, and to explain why operating a scour valve, for example, is so important. You're actually doing the task that they would do in their job, but you're training at the same time. That can be done an hour here, half a day there, when it fits in with the workload. So it doesn't take people away from their day job.
Thanks very much, Neil. And with this, I think we're coming to close. We are on time. The only thing that it remains is to express our sincere thanks and appreciation. First of all, to the speakers for their time and willingness to participate in this webinar. I'm just reading, from the chat box. Panikos Pashas, he also would like to express his gratitude and appreciation for the excellent presentations. In addition, I would like to add on behalf of the management board of the Cyprus Water Association, our sincere thanks to the three speakers for sharing with us their knowledge and expertise. many thanks to the Water Development Department for preparing this joint webinar on this very important subject. To our young water professionals who are very active in the Cyprus Water Association, and we all strongly believe that they are the future in our water sector. Many thanks to them for their organization behind the scenes with all technology that the seniors in the association are not very, if you like, familiar with such methods. And lastly, to the participants, I've seen that constantly we'll be having around 36 right through the 2 hours. So sincere thanks to the participants, all the participants, for their patience. I hope that it has been interesting for everyone. The presentations will be available on the Cyprus Water Association's website to be downloaded, and there will be a link to the recording of this session. Presumably the file will be huge, so there will be a link that anyone wanting to either watch it again or to see it for the first time, it will be available. With this, I would like to bring this webinar, which in our opinion has been a successful webinar on such a very interesting and important topic, to a close. I wish you all to have a great day, and hope to see you soon again in 2021 in another similar webinar to this one on another subject. Thank you very much, everyone, and have a lovely day. Many thanks.
That's right.